be worth sampling in the winter as long as you can, as long as it's safe and the water is available because of the seasonality. This is also a really large catchment area. Just want to draw your attention to 127 miles squared. These are big catchment areas. So, and there's streams up further, by the way. So I took like the mouth of a lot of streams just to get the largest area that I could. So there are more sites up here. Okay.
There are 2 new gravel mines since the beginning of our data collection.
Really? Okay.
Within that drainage area.
Okay. Do you know where approximately around here?
Yeah, one is at the headwaters of the Wilseyville Creek.
Okay.
Kind of going in the wrong direction.
Up here?
Yep.
Yep.
There.
Okay.
And another one is west on Catatonk.
Okay.
So.
All right. Well, that's good to know. Yeah. Tying me right into something we need to talk about, which is land use and stuff. So Patterson Creek is a funky little catchment area. It's tiny. It's only 4.5 miles squared. R squared is quite a bit lower. Again, it's not necessarily a big deal. And we're going to talk about Patterson Creek some more when we talk about nutrients. And so keep this correlation graph in mind. Notice the variation, the deviation from that trend line and how it differs from the other creeks we've looked at thus far, and what might be the cause of that. Again, the seasonality is, where is my laser? Oh, I think my dad can do it. It's okay. Notice the seasonality still somewhat the same. And then really in particular, notice the land use, but we are going to come back to that. So, Meadow Creek at Georgetown Pullover, this is very far east. Okay, so we're going to look at the map again, but so we just covered a bunch of creeks that are all sort of in the same area, southern tier portion. This is further.
Nope. I started my teaching career there.
Yeah. So
and that community in the late 70s described itself as 100 cows per person and 100 deer per cow. It's no place.
Yeah, so it's out there. I didn't put the confidence intervals on here because my program glitched and it wasn't working, but you can imagine them. And again, we have a little bit of variation going on right up on the correlation graph, but again, you can sort of see the seasonality. There's some gaps in the data a little bit that make it a little hard, but it's still definitely there. Okay, so Oriskany Creek. Oriskany Creek is interesting because it is very agricultural. So if you take a look at that catchment area, the land use. I'm sorry, this is very obvious to me, so I didn't explain it, but brown and tan is agricultural land use. Different shades of green, forested, red, or red, pink, urban. Yeah, okay. I just so ingrained that I didn't even think about it, but so Oriskany Creek is way up near Syracuse, east of Syracuse, and so is Limestone. And so what's interesting about Oriskany Creek, and I do want to draw attention to this, look how much higher the total hardness and the conductivity is compared to those other graphs. So if you've been paying attention to the axes, and let's just go back just for comparison to Fly Meadow, on the range from like 30 to 80 for total hardness. They have really, really low, but you get the idea. And then you look at Oriskany, and the range is more from like 200 to 350 for total hardness. So.
Is that because of land use or just the makeup of?
Well, yes.
Syracuse is Salt City.
Yeah. So
That's its nickname because it's the source of the salt that seasoned all of the colonial American food and all of the Native American food because of the surface abundance of table appropriate salt.
So we're gonna talk about what makes it different. So because limestone's the same way. Limestone again has that really quite high total hardness and conductivity. So I was like, that's cool. So let's look at the natural geology in the area. This map is like total madness, but bear with me. So we've got this column here to Finger Lakes region. So let's like keep within that. And then if you look to where Finger Lakes, Seneca Lake, Cayuga Lake, the majority of the red flag that we've already looked at, right down here, and this green and this tan. Now, Syracuse, so here, yeah-ish. So Oriskany and Limestone Creek are right about up here. So my thought was, well, those are two different colors, so let's take a look at that a little bit more closely. So that's a zoomed in view of it. And so the green and the tan, okay, that we're looking at, so that's this and this, SH and SS, shale and sandstone. And then we look at this blue and we get some of this LS, limestone. I am not a geologist at all, but I did think that was an interesting difference in the geology. And you know, considering the high conductivity and high total hardness for both Oriskany and limestone and Chittenango, yep, and Chittenango, which is a stream right next to those other two. You know, the geological difference between that region and the region that a lot of these other streams in, it does fit. But again, I'm not a geologist, so I'm doing my best to read this really intense geological map. But that's the idea that I came up with. Okay. So the importance of nutrient monitoring. So I've got a lot of questions today about nutrient monitoring and where that's headed. So it is relatively new to the red flag program, but it's a really important key addition as we move forward. So as I mentioned, phosphorus is the limiting nutrient for the majority of freshwater autotrophs. So that means that an overabundance of phosphorus and other nutrients can lead to eutrophication. This is a harmful algal bloom, right? This picture here on the James River in Virginia. So this is this river right here entering the Chesapeake Bay. Okay, this is like right there. This is this big bridge that crosses the mouth of the river right before it enters the Chesapeake. And my point in highlighting this is that many of the red flag sites, Limestone, Oriskany, and Chittenango excluded, are in the Chesapeake Bay watershed. That headwaters part up here, that headwaters part, that's where all of those red flag sites are. So we're gonna look at that. Okay, so this is I think the slide that you guys all spent a lot of time looking at already. But come on. Yeah, so the black line here, big black line on the map, that's the boundary line of the headwaters of the Chesapeake Bay. So you can see how it sort of lines up, and you can see that the majority of the red flag sites do fall within it. And so the other thing I want to highlight with this that you've already probably looked at is the total phosphorus, the concentrations that we've gathered thus far. And I will note there's not a ton of them, so these averages are based on 3-4 points at the most. So it's not a lot of data yet. We're working on it though. And so what we get here is this spread of total phosphorus concentrations. So what I've done is I made this legend. So dark green, total phosphorus is between 0 and 10 micrograms per liter. Light green, between 10 and 20. Yellow, between 20 and 30. Brown, between 30 and 40. Orange, between 40 and 50. Red, greater than 50. The guidance level, the limit that we sort of hold ourselves to is 20. Okay, so that's why they're green. Green for go, green for good. You know. Tried to make it as intuitive as possible. So anything above that 20 is like, anything above, 40, 50, that's like really kind of not great. So I will take a second to highlight, the 3 points that are above 50. Got this guy here. I don't know much about that guy, so we'll not talk about him. We've got, this is Upper Cayuga at 224. And then this is Patterson Creek, right there. Okay?
So that's the one we did, the red one. Is that the one you're pointing?
Down here, yeah, it is.
Okay, because.
That's
we
yours.
brought that, yeah.
Okay, good,
So we
good.
brought in the sample.
All right,
For the testing.
perfect.
Several months ago.
Awesome. Well, I'm glad we can keep doing it then, so we can get some more data on that high point. Okay. So what is up with Patterson Creek? Because it is consistently the highest total phosphorus concentration of any of the sites. So I looked at the land use. I talked with Bill. I looked at the satellite imagery. We're trying to figure it out. So we're going to go through a little adventure with Patterson Creek here. Okay. So, Bill, you usually take the sample down here under the dam, right? Okay. So, which is near a bunch of athletic fields, baseball fields, soccer fields, etc. It's just an athletic complex area. So the total phosphorus has often been high, above 50. So I was like, this is weird. Bill and I agreed it would be a good idea to take a sample north of the athletic fields here. This pink area, this is a golf course. That's why it's pink, because it's developed. So this is a golf course. So I was like, hey, let's take a sample north of that. So then Bill went and took a sample.
Probably right up where those two.
I have an arrow that points especially to it. Darn it. Oh, Andrew, could you get the charger out of Steve's laptop bag? I forgot to plug it in. I don't know. Okay, Steve, could you grab that? Oh, it's right near me. Sorry. I brought it over. Never mind. All right. So I'll just keep talking as I go through this. So then Bill took a sample right there. Okay. And why am I not seeing it? The power cord for the laptop. And so he took one there, and I was like, okay, let's see if that explains it. And then the concentration was 82.6. So what's the source of all the total phosphorus? And this 82.6 thing, this all happened yesterday because Bill called me and was like, hey, what was the concentration of that site I took? I was like, oh, wow, that's kind of high. I'm going to make some slides on this.
What are the pink lines? Are those roads?
Those are roads.
Okay,
Yeah.
thank you.
Mm-hmm. Yeah. Yeah, those are roads. So then, oh yeah, that's a dam. Okay, so I thought, okay, this is potentially related to land use at this investigative site because it has changed significantly over the past few years. This is where it gets fun, okay? So just indulge me because this is like being a private eye. So this land use imagery that I've been showing throughout this talk is based off the NLCD 2011 database, land use database. That's a raster dataset, GIS thing based off of satellite imagery. Comes out every 5 years. The 2017 data is not yet available, which is why I'm working with the 2011 data. This is right near Bill's site. You can see Bill's site, yellow pin. This is the satellite image on October 2011. Okay? And then from that same, so that's the site, that's your little box. So then, you look at 5/2015, looks pretty much the same, right? It's really not that much different. And again, remember the land use type. So you've got your dark green, which is coniferous forest, light green, which is just deciduous. Okay, so that's what you've got here. This is 2017. So I got confused because when I looked up the Google Earth imagery and I saw that and I was like, well, that doesn't match my land use. So that's when I looked back. And so this logging operation here and this random pond all happened within the past few years. I don't know what date exactly, but this was October 2017. So, Bill, this pig farm, is that right in that, is that the pig farm? Where is the
I'd say so, yes.
Okay, so Bill thinks that this operation right here is a pig farm. So now we've got 4 different potential sources of phosphorus at this tiny little catchment area. The athletic fields, the golf course, the pig farm, and whatever this thing is. This logging operation, which is probably stirring up a bunch of sediment and making erosion like really.
They did a clearing operation in that area. I don't
Yeah.
know how many years ago.
Yeah, so this is it. Yeah,
Yes.
yeah. Yeah, so I mean, it was in the past few years because it was
Yeah.
totally forested in 2015.
Can you
So,
point out the line of the stream? I can't really tell where that pin is next to a road.
yeah, yeah.
Stream's running.
I can't really tell either. I think this is a stream right here. It's a little tricky because I plugged in the GPS coordinates that Bill gave me, and then that's what
Okay.
popped out. But I believe it's right up. It goes under the road, I believe, like down that way. Yeah, I know it's a little tricky. Oh, there. Is that what you think it is, Andrew?
Yes, you can see it on the other side. of the
Oh,
street.
okay. So it's this right there. Yeah.
So it goes between the clear cut and the pig farm.
And the pig farm. Yeah.
No, that's a ravine,
Yeah. Yeah. So it goes right through here, right through this like little.
It's probably a little ravine.
Yep. Okay.
You can see, in fact, towards the upper part of the slide, just to the left of the logging operations, you can actually kind of see the contour there.
Yeah. No, I see what you're saying. Yeah. And so the other thing is that pond wasn't there.
Something they're gonna do in the future.
Isn't that like look at that
Wow.
pond? No pond. Pond. No
But it was a
pond.
wet area.
Yeah.
It's clearly a wet area.
Yeah. Yeah. No, I have the same thought. So, I also wanted to mention, and this is where I deviate from the presentation just a little bit, that everything I was able to do, for the most part, you can also do using a lot of cool software that exists. So I'm just going to show you a couple of those tools. So you all know about the database. All right, so CSI's water quality database, and how you can go look at your data, your streams and lakes. Sorry. So a lot of your streams are in the upper Susquehanna River watershed. You can see them all: Cayuga Creek, Catatonk Creek, Meadow Creek, River County streams. That.
Wilseyville Creek is not on that list? Or no, they're not alphabetical?
They're not alphabetical. They're by date when they were added. Yeah. Wi-Fi is really slow. But then the other 2 pieces of software I wanted to show you were this thing called Wiki Watershed, which is pretty fun. So basically the way it works is it allows you to look at the land use in an area and the catchment area delineation. And so you can delineate a watershed, okay? You can select a boundary, which is what I'll do. I'll do subwatershed unit features 12. So then it breaks it up into these pieces. You click on one, and then it's going to give you all of this stuff about this catchment area. So it's going to list the stream orders, the land use, which is what I've been showing you using the maps. Soil, terrain, climate, whole bunch of stuff. Animals, that's fun. I didn't know that was a choice.
717.
Water quality usually doesn't have anything under it. But it is a good way to at least get an idea of the land use if it's something that you are curious about. And it gives the percentages. So that's really nice. Stream Stats does something similar, and it's decided not to work. But with Stream Stats is how I delineated all of those custom watersheds. You know, the Weston Creek, the Patterson Creek, those aren't watersheds that are, those aren't defined by USGS. I had to make those. So the way you do that is, well, you would click on a point, and then that point would delineate the watershed. So if you click on a point, it's going to calculate all of the area upstream of the point that you click on, and it's really quite handy. I'm going to zoom into New York here. Can't zoom into that now, so that's okay. But you guys get the idea, and it's a good thing to play with. So I will put the these sources up when I put up the PowerPoint and everything, because it's really just fun to play with. It's pretty intuitive. It does take a little bit of practice going through it, but it's really quite fun. So yeah, all you do is, once you have to zoom into a level 15 or greater. Right now we're at level 8. So you have to zoom into 15 or greater, and then all of the streams are going to become little blue pixels, and you click on the blue pixels, and then it delineates your watershed based on the point. And then there's a bunch of options. You can look at the drainage area. That's how I got the drainage areas for all of your catchment areas. Slope, rainfall, anything. So it's a really fun thing to play around with. Oops, we're not PowerPoint anymore. Okay.
Great.
So, yeah, on that note, catchment area land use is really important to consider when looking at nutrient concentrations. That's what we just talked about with Patterson Creek and these other creeks. And so this is just to give you a scope of the land use in the entire region. And it's just an intense slide, so don't feel bad if it's very confusing. But I do have the sites. All the black dots are areas that don't have any data. And then you've got your color scheme once again, but you can see some of the major trends. You can tell how agricultural the Cayuga Lake watershed and Seneca Lake watershed are compared to, well, anywhere else around the area.
So, at our site, we're thinking of moving where we test the creek. But how will that impact the data, and how much variation can we use? We had access, and then the landowner withdrew that access, and so we moved down creek. Is it up creek a little, and we want to move down creek? So
Okay.
it's not, it's maybe a quarter of a mile, third of a mile difference.
I mean, it depends a little bit on whether or not there are any confluences between that original point and your new point. If there are, then your catchment area is going to increase by a lot, probably.
Okay.
So that could make a difference.
So how do we do that? Do we send you
Yeah, why don't you send me the GPS coordinates?
the GPS?
Yeah, send me those and I can take a look at it compared to your older site. And also send me the site that you used to sample and those coordinates. And I'll compare and we can talk about what makes sense.
Okay.
So yeah, that's I think how I would approach it. Okay, since we're on the topic of nutrients, harmful algal blooms. They're a huge topic right now in the state of New York. And so we're going to talk a little bit about what they are, how they're related to nutrients, and what New York State, CSI, and other organizations are doing right now to address the increased presence they've had in the Finger Lakes. Because I'm not sure if you know about Governor Cuomo's initiative, $65 million to address harmful algal blooms. But it's very much on my mind, and HABs are kind of consumed my life these days. So harmful algal blooms are actually bacteria. They're not actually algae. They are